Another place we talk about energy of chemical reactions is looking at calories in food. And so we have to have some way of measuring these values, but we're going to look at one, how it's measured, and then how we can calculate it based on what we knowing about the components of that particular food. So here we're actually looking at something called a calorimeter, and this is simply a device for measuring the heat released or consumed by a reaction. And so what happens is that we have this container. Sometimes these are called a bomb calorimeter because they're usually made out of a really heavy metal, like a big steel container. We have this combustion chamber where we're basically going to burn some food sample. And what we're going to do is we're going to see how the temperature of the water changes as this reaction occurs. And by understanding how much heat is put out into the water, which is typically what we're looking at, is we can figure out how much energy was changed, and we can go back and figure out the calories in food. And so if we're actually looking at the calories in a very specific food item, this is what we have to do. Now we're going to look at some numbers that help us kind of figure out what it is in general, but this is kind of the experimental method for determining those values. So anytime we buy food, we see that there's a label on the back that tells us about carbohydrates, protein, fat, and calories. And there's some other assorted information, the different types of fat. But what we're worried about is these three main categories. And what we're looking at is how many calories are in that particular item. Now, one thing we need to be worried about here is that calories has a big C on it. And so when I write calories with a big C, that means I have 1,000 calories with a little c. So what we're showing here in this graph, or this table rather, is that we have our calories and then in parentheses that are showing the value in kilojoules. So when we're talking about food and nutrition, we're typically talking about it in terms of calories, but in chemistry we tend to talk about energy in terms of kilojoules, and so that's why both numbers are given there. So what we can actually see is if I look at an apple, for example, it has 21 grams of carbohydrates, 0.27 grams of protein, and 0.49 grams of fat. Now, if you looked on the label of something with a fruit, what you're going to find on the packaging is that you're really not going to see any protein or fat because the values are so small that they can actually round those to 0. But what we can do is figure out the calories we have per amount of those substances. So if I look at carbohydrates, for example, for every gram of a carbohydrate, I have 4 calories in a substance. For every gram of protein, I have 4 calories in a substance. And for every gram of fat, I have 9 calories per gram. And so these three numbers you do need to know. You should be able to do these calculations that we're going to look at an example of on the next slide, but you should know how to do those. So it's 4, 4, 9, carbohydrates, protein, and fat. But you have to be given some information about the grams of each of these components in the substance. So let's look at an example here, and the only reason I picked Hershey Kisses was because I happen to have some sitting on my desk. So we have 1 serving of Hershey Kisses with caramel, so that's 9 pieces, has 9 grams of fat, 27 grams of carbohydrate, and 3 grams of protein. How many calories? Now notice that I wrote this with a big C, which tells me I have to put this in terms of calories, so it matches up with my data down here. Little c calories is not the same as big C calories. Part of this is a PR thing. If you picked up a package of M&Ms, you probably don't want to see that it has 200,000 calories with a little c. It's much more appealing to look at it when you see it has 200 calories. Even though the values are equivalent, looking at a big number like 200,000 is probably enough to deter you from purchasing those M&Ms. So here we want to look at how many calories are in this one serving. And so what I look at is it tells me I have 9 grams of fat. So I start by saying 9 grams of fat. And I'm going to multiply that by my calories per gram. So 9 calories per gram of fat. And then I'm going to add to that my calories from the carbohydrates. So we have 27 grams of carbs. And I'm going to multiply that by the calories per gram of carbs. So I have 4 calories per gram of carb. And then I will add on, I'm going to run out of room here, so I'm going to go to the next line, 3 grams of protein. And that also has 4 calories per gram of protein. Now, because the protein and the carbs have the same number of calories per gram, if you wanted, you could actually combine these and just say 30 grams times that 4 calories per gram. I'm showing the entire process, but you can definitely do that shortcut and it not change your answer, only because they have the same calories per gram for both carbs and proteins. I can't do that with the fat because we have a different number there for calories per gram. Now I'm simply going to add this up, so I'm going to take 9 times 9 plus 27 times 4 plus 3 times 4, and what I get is that we have 201 calories. Now, what I'm looking at here is, on this case, I'm not going to worry about my significant figures when we're looking at calories, because most of the time it's reported to 1 sig fig. We have to report our answer. So if I wanted to write this with 1 sig figs, I could write it as 200 calories. For the most part, I'm not going to worry too much about that, just because it keeps life a little simpler, and well, it's just one less thing to worry about. So now we get 200 calories in this one serving. So now I have this based on my carbs, proteins, and fat. And I can do this for any substance if I know the grams of each of those components. So now the question becomes is, how do we get artificial sweeteners? How do we have things that have no calories but they still have bonds, they still have components to them? Well, when we look at nutritional calories versus we look at energy, those are a little bit different. If I looked at the energy stored in the bonds of some of these artificial sweeteners, I would see that there is a significant amount of energy in those, similar to what we see for sucrose or table sugar. I would see calories or energy stored in there. The difference is that when our body takes in sucrose, it actually breaks it down, uses those carbs, and so there's an energy associated with that process in the body. When I look at other artificial sweeteners, and there are a variety on the market today, what I see is that our body doesn't know what to do with these. And because our body can't break them down, we can say they have 0 calories. So even though from a chemistry standpoint, they still have energy stored in those bonds, because all bonds have energy stored in there, our body doesn't know how to process them. Therefore, it doesn't do anything with them. We consume them. They interact with our taste buds in a very similar way because of their similarities in structure or some property that allows them to interact with our taste buds in the same way. But since our body can't break them down, our body simply passes them through, we don't actually see any calories, nutritional calories, from these items. So that's why we can advertise these as 0 calories, even though we have energy stored in the bonds.